This is computer-aided diagnosis system, which is helpful to detect the diseases in early stage. And we are giving some modules within this application. So let's get start with how we can build this kind of application. What are the technology we are using? So let's start. This is the table of content for this video we are following. So let's go to the introduction part. We are using machine learning and deep learning technology in this application. So for your basic overview about machine learning, it is like machine learning is basically an application of artificial intelligence, and it's have an ability to automatically learn and improve from the experience without being explicitly programmed. So machine learning basically learn automatically from the historical data. So machine learning is the type of machine learning is supervised, unsupervised learning, and one more kind of machine learning is there, the semi learning, or we can say is the reinforcement learning. So we are going to use supervised learning in this application. Basically, why this application is very important: based on the World Health Organization estimated 17.9 million, around 31% of deaths occurred worldwide due to the heart disease. So that's why heart disease we included in this application to detect in early stage. You can see the data here. So this is also the data regarding is classified based on the male and female death ratio. Males are 52% and female 48%. The data is also classified in the form of age group wise, you can see here. So that's why it is very important to make an application uh, which can help us to detect the diseases in early stages so that we can save the human lives. The second disease we included in this project is breast cancer. Again, according to the World Health Organization's 2.1 million women each year uh, impacted through this breast cancer disease. In 2018, it is estimated that 6,27,000 women died from breast cancer. So this is approximately 15% of all cancer deaths among women. So that's why we included the breast cancer in this project as well. Major objective of building this kind of application to create software system that will give information about the disease using the latest technology and more accurate data which is provided by the scientific researchers. They, there is an effort to create a better system with the help of updated data, because we are getting updated data from new kind of variant each and every disease. So we update the system based on that new data. The advantages of this system, basically, we can get accurate information about the disease when input is given by the user according to the parameters. So in this system, whatever we are going to build based on user data, user input, we give them results, and these parameters are fixed, and the parameters are the genuine parameters, also used by the health industry experts. So we are including only those parameters which are relevant to these kind of diseases. And with this help, accurate information of multiple diseases will be available through single window system. We are developing an application where we can get the disease detection regarding health of heart disease, and another one is breast cancer. We are introducing uh, disease diagnosis based on the symptoms, and one another option is also there to detection COVID-19 disease detection. So this kind of functionality we can add with this software as well. Whatever we are using technology, or we can say the data, this data we are feeding in this application is basically demo, but itself this is not a fake data. This is the data which is released by the scientist from the healthcare industry. Okay, these are the more advantages of this application, and we are using well uh, algorithms, the algorithms which have good accuracy, and prediction percentage is higher, and the precision rate is at as good. So the algorithms we are using basically regression, and different kind of algorithms we are using. So you can see the overview. I'm not going to explain each and every algorithm in this video because it's take a little bit time, so I'm skipping the explanation of all the algorithms. Basically, regression is an statistical measurement to use to determine the strength of the relationship between dependent or independent variable. Basically, dependent variable is the target value. Whatever is the target means, if we are targeting any variable, this is the disease is true positive or not, we are denoting 0 to 1. So that means that column is called the target value. Based on that target value, we are deciding either it is uh, uh, affected one or not. So that is called dependent variable. And independent variable, all the inputs we are giving to that model, that is these are called the independent variables. So this is the logistic regression, as you can see, and this is the sigmoid function for logistic regression. You can see the plot in the graph. The second algorithm, the KNN algorithm, K nearest neighbor algorithm. You can also see all the more detailed information through Google about this algorithm. Third one is decision tree. You can see here the classification of decision tree, how it works, the workflow of the decision tree algorithm. These are the all the related works through the journals what we have learned, and we implemented this application for the project. Okay, the tools and technology we are using in this application is Python programming language we are using, and we are using machine learning and deep learning as well. So the proposed framework is like, this is the workflow what we are going to use in this application. How we are collecting the data: the first one is data collection. The data we are collecting regarding to the heart disease, breast cancer, and many other thing. And after that, we are pre-processing that data. The pre-processing is the second part, because we know the data is noisy. In many cases there are some corrupted data. There is an a string in form in place of the numerical value, and in some part it is a blank empty data. So that is the part of removing these kind of entities from the data, that is called data pre-processing, so that our model can give more accurate result. Third part is model training. Based on that pre-processed data, we train our model using different kind of algorithms. So we split our data into test and training parts, and we train our model like to 20 or 80. We divide our data set into 20/80 ratio, and we train our model with 80% of data, and after that we predict the result. And after predicting, we validate the data with the testing data, 20% of data with the predicted data, so that we can give the results. So this is the basic workflow. This is TFD level 0 for this application. This is level 1 DFD for this. These are the hardware and software requirements for this application. This is the basic interface of this application, the computer aided diagnose system. Here we have prediction diseases. Second one is diagnose disease. In prediction disease, basically we first choose the algorithm, choose the disease, and set the data. After that, we give inputs based on the specified parameters through the health industry, and after that we give the results. In second module, we have diagnose disease module, where we give 5 inputs regarding the symptoms, and after that we give the result regarding, based on these symptoms, this disease can impact, or this is the disease the person is impacted. So the third one is neural network. Basically in this module we give an image based on the breast cancer, if we can say. So we feed that image into our application, and after the analysis, the machine our application will predict either it is affected through this kind of breast cancer disease or not. And fourth one is COVID-19. So let's go to the application part, the demonstration of the application. This is basically for prediction disease. Here you can see, first we choose heart disease, and then the algorithm what we want to choose, and we inserted these kind of data with this application. And after inserting these data, we click on process and we'll get this kind of result. This is basically the model accuracy. You can see in the result, disease prediction, the model is saying 57% of the 57% chances are there to be impacted through this heart disease. That person is impacted through the heart disease. So these are the details. Based on the disease prediction, we can identify the disease. This is the graphs visualization of this data. We are giving this graph representation in this application as well. This is for the cancer detection. In heart disease there are less parameter, but in cancer we have more parameters. Here you can see we enter the data in numerical form, and after inserting that data into the application, we process, and after we get the result. And the algorithm we used here is decision tree algorithm we used. So you can see disease prediction is 1. It means yes, the breast can the patient is affected from this kind of disease. It's 100% prediction from the decision tree algorithm, and model accuracy is 92% more accuracy of this model. Now this is the diagnosed disease module. Here you can see the interface. In this first section you can see we give the input, your patient name, gender and age. After that we give 5 symptoms. We ask to the patient what kind of symptoms you are feeling, like headache, whatever, back pain, whatever. Okay, so after choosing these five symptoms, we uh, process this data through our models, and based on these kind of models we get the result like 87%, 89%, 82%, and we generate the result after clicking on generate report generation. Okay, so this is the patient report we generated through this. So this is the demonstration for a patient XYZ. First symptom is chest pain, second is fast heart rate, loss of balance, cramps, hip joint pain. So based on most of the algorithms, navy Bayes and random forest, the result is saying 84% of chances of hypertension and one is pneumonia. So there is a chances of hypertension to the patient. So this is the model. Okay, and this is the result. After that, this is an added module for COVID-19. These are the symptoms. This is the basic interface for COVID-19. These are the symptoms we are entering in this model, this application interface, and we get this kind of result like this. Yes, this patient accuracy 100% and prediction is 100%. It means this person is affected through the COVID-19. Okay, here is the health guideline as well based on the results. Okay, test shows that you are infected with COVID-19. So this kind of application we can develop through ML and deep learning. And this is the basic format for the uninfected through the COVID-19. See, all the symptoms are 000. It means that no symptoms found. So you can see the result. It's saying you are likely less likely to be infected. So it's giving a proper result based on the symptoms. This is image processing through CNN. This is basically a part of deep learning. Here we are using this kind of all the images which we uh, got from the scientific research, so we use and we got this kind of result from the analysis. So that's all in this video. I hope you get some knowledge about ML, deep learning, how we can use AI to improve the health worldwide, so that we can save people's life in early stages. Thanks for watching this video. Please do subscribe this YouTube channel for more videos like this. So that's all. Thank you.